In this lesson, we'll examine the question, what is a database? Let's imagine for a moment that we're in a room with the telephone books for the 50 largest American cities. I tell you to find the phone number of Carl Roth in Los Angeles. What would you do? Simply pick up the Los Angeles telephone book, flip to the R's, and find his number. Not terribly difficult. But what if, first, I tore out all the pages of each book, threw the pages in the air, and scattered them on the floor? Then I asked you to find Carl Roth in Los Angeles. That task is considerably more difficult. This is a good example of why the database is so important. Think about all the information about you that exists in databases. Hobbies, our preferences, our interests, purchases that we've made, friends that we have. All of this information must be stored somewhere, and the vast majority of it is stored in databases. Put simply, a database is an organized collection of data. Computers use databases to organize and store that data in a way that it can be easily retrieved. But the kind of databases we have today haven't always been in existence. The first computers were primarily used for computation in scientific research and even some military applications to calculate numbers quickly. As time went on, businesses began to use them as well. When they came into more common use, requirements increased to be able to store much of the data that was being calculated. As more data was stored, new ways were required to preserve and retrieve that data quickly. The first databases were called flat file databases. A flat file database is something that we're basically familiar with. If you've ever seen a comma-separated values file, or CSV, you've seen the way a flat file database is stored. Let's look at an example of some simple flat file values. Here we see first name, last name, and other information about our customers in the database. Notice that the first value in each row is the first name, and the second value in each row is the last name. This is consistent across all of the values. The data is read from essentially left to right. The first value is read, then a comma delimiter, the second value is read, and so on and so forth. Each individual value within that row, separated by commas, is called a field. This data was generally accessed using programmatic methods that read individual records. This example of a flat file database is very limited in that there's only a few records and fields. In a real flat file database, there could be millions and millions of records and hundreds of fields. This is one of the problems that developed over time. The flat files grew unmanageable. Another approach was needed to be able to manage this type of data. That's where a man named Dr. Ted Codd comes into the story. Dr. Codd, employed at IBM at the time, was working on a solution for some of these problems. In the 1970s, Dr. Codd presented a paper that introduced a new type of storage paradigm for databases, called the Relational Paradigm. The Relational Paradigm was a way to deal with many of the problems in typical flat file databases. The Relational Paradigm depends on organizing information into what's called entities and attributes. An entity is any person, place, or thing. Attributes are things about that person, place, or thing. So we might organize our information the way you see here. We have an employee entity that has attributes such as first name and last name. Thus, we can organize all of the information that we've had in flat file databases and put it into an entity attribute structure. The real strength of Dr. Codd's relational model is that the information can be related to other information. That is to say, we can relate one entity to another. In a flat file database, all the information about a given employee would basically be in a single record. In Dr. Codd's model, we separate that information out and relate it. Here we have employee information and address information. Dr. Codd's theory was that similar pieces of information could be structured in such a way that they formed relationships. So rather than combining numerous pieces of information together in the same structure, we instead separate them out into related pieces of information. Because both of these entities share a common piece of information, in this case, employee ID, they can be related. This type of database is known as an RDBMS, or Relational Database Management System. So why is this model better? The primary reason we use an RDBMS is the removal of duplicate data. Consider an order entry system with customer records. If an individual places numerous orders, the customer's basic information, such as name and contact information, must be stored in every record using the flat file method. With the relational method, we simply have an entity for customer information and another entity for order information. We then relate them together. The process of transforming a flat file data model into a relational one is known as normalization. Today, we refer to an entity as a table and records and fields as rows and columns, respectively. The RDBMS has been the data storage model of choice for 3 decades now, and although Oracle is the RDBMS with the largest market share, there are other popular systems as well. IBM's flagship database product is known as DB2. It evolved from their first RDBMS product called System R. It is very popular with customers that use IBM hardware and includes the ability to run on mainframe systems. Oracle actually has another RDBMS that it provides, although it is free of licensing restrictions. When Oracle acquired Sun Microsystems, they also acquired the MySQL RDBMS and continue to support it today. SQL Server from Microsoft is another popular RDBMS. Microsoft began work on SQL Server when they purchased the code base for Sybase SQL Server from Sybase. Although popular on Windows systems, SQL Server lacks the cross-platform abilities of other database systems since it cannot run on any other operating system besides Windows.